All right, so we're diving into open source physics education today, and you've given me a ton of documents about this workshop in Singapore.
Yeah, back in 2014.
Yeah, 2014.
Seems like they were really ahead of the curve.
Yeah, it seems like it. So what exactly were they trying to do?
Well, the Ministry of Education in Singapore, they sponsored this whole 4-day workshop at the
Wow.
Academy of Singapore Teachers. They really wanted to get educators hands-on with computational modeling.
So they were like, okay, everyone, let's build some simulations.
Yeah, basically. And they brought in the best of the best to lead this thing.
Okay, who are we talking about?
Wolfgang Christian and Francisco Esquembre.
Ah, yeah, I've heard of those guys. They're like the rock stars of physics education.
They really are. And what's so cool is that they've both dedicated their careers to making physics more accessible to students.
Yeah, they've developed all sorts of tools and resources that are used all over the world now.
Exactly.
So let's start with Wolfgang Christian. He's a professor at Davidson College, right?
Right. And he's the founder of the Open Source Physics Project.
OSP.
Yeah, OSP. Think of it as this massive online library of physics simulations, source code, all kinds of teaching materials.
And it's all free.
Totally free. It's a perfect example of open educational resources.
Which is like this movement to make knowledge available to everyone.
Exactly. And Christian has been a huge champion of that movement.
Makes sense. I mean, the guy's won a ton of awards for his work in physics education.
Yeah, like the Pegram Award.
Yeah.
And he's a fellow of the American Physical Society.
Not too shabby.
Not at all. Okay, so now let's talk about Francisco Escumbre.
Okay. He's at a university in Spain, right?
Yeah, the University of Murcia. He's an associate professor there.
And he's the guy behind Easy Java Simulations.
EjsS.
Yeah.
That's the one. It's this software that lets teachers create interactive physics simulations.
Ah, so it's like bringing those abstract concepts to life.
Exactly. And Escumbre is super involved in all sorts of organizations focused on using technology to improve science education.
Like which ones?
Well, he's the president of the Multimedia and Physics Teaching and Learning Group, and he's also the president of the Colos Association.
Man, he's a busy guy. So both of these guys are like pioneers in physics education.
Yeah, they're the real deal.
And they came together for this workshop in Singapore to teach other educators about these open source tools.
Yeah, and the goal was to get those teachers building their own simulations.
So they're not just learning, they're creating.
Exactly. They wanted them to become active contributors to the open source movement.
I love that. So, how did they actually structure the workshop?
Well, they made sure everyone had a computer to use,
Mm-hmm.
and they had this mix of lectures, hands-on sessions, and one-on-one consultations.
So they were really making sure everyone got the support they needed.
Yeah, totally. And they started with simple, real-world examples,
Like what?
like the gravitational n-body problem and the simple harmonic oscillator.
Ah, okay, things that can be kind of tough to grasp without a visual.
Right. But with simulations, students can actually see how those systems work.
They can play around with the variables and really get it.
Exactly.
Yeah.
And as the workshop went on, they moved to more complex simulations.
So they were really getting a deep dive into computational modeling.
Yeah, it was pretty intense. But the cool thing is that they always encouraged the teachers to adapt the simulations to their own needs and their students' learning goals.
So they were making it their own.
Yeah, they weren't just copying what they saw. They were taking those ideas and running with them.
I like that. Now, you mentioned something earlier about them working with the Ministry of Education.
Oh, yeah. On the second day of the workshop, they actually brought in people from the Curriculum Planning and Development Division.
Wow, so they're really trying to make this a part of the education system in Singapore.
Yeah, they were thinking big picture. They weren't just focused on this one workshop.
Yeah.
They wanted to see how these open source tools could be used to transform education as a whole.
That's pretty ambitious.
It is. But they were really serious about it. They had discussions about blended learning, MOOCs, open educational resources, teacher learning communities, all sorts of things.
So they were really covering all the bases.
Yeah, they were. They were thinking about how to create a more engaging and effective learning experience for all students.
And did they see any success?
Oh, yeah. Out of the 20 teachers who participated, 10 of them created their own simulations.
Wow, that's awesome.
And 7 more adapted existing simulations to use in their classrooms.
So they were really putting what they learned into practice.
Absolutely. And they were excited about it.
Yeah.
We even have a quote from one of the participants, Leong Tic Wang. He said he felt incredibly inspired and motivated by the workshop.
That's great. And one teacher even started working on a research grant based on what they learned.
Really? That's fantastic.
Yeah, it's amazing to see that kind of impact. So this wasn't just a workshop. It was like a catalyst for change.
It was. It sparked a whole movement towards more creative and hands-on approaches to teaching physics in Singapore.
And who knows, maybe it'll spark something bigger. Maybe other countries will start to see the potential of these open source tools.
I hope so. It would be amazing to see this kind of innovation spreading all over the world.
So we've got these two amazing guys, Wolfgang Christian and Francisco Escumber, leading this groundbreaking workshop.
Yeah, it's a pretty incredible story.
But I'm curious to learn more about their backgrounds. What led them to become such leaders in physics education?
Well, Christian's journey starts at Davidson College.
Okay, that's where he's a professor now, right?
Right. But he's been there since 1983.
Wow, so he's been there a long time.
He has. He actually started out focusing on physics research. He got his PhD from North Carolina State University.
So he's got a strong foundation in the theoretical side of things.
Definitely.
Hmm.
But he quickly realized that he loved teaching.
And that he had a passion for making physics more accessible to students.
Exactly. And he saw computers as a powerful tool for doing that.
So he kind of became this pioneer in computational physics.
He did. And he's been really involved in professional organizations like the American Association of Physics Teachers.
So he's not just a researcher and a teacher, he's also a leader in the field.
Right. He's been a strong advocate for innovation in physics education.
And his work has been recognized. He won the Pegram Award for Excellence in the Teaching of Physics.
Yep. And he's a fellow of the American Physical Society.
Pretty impressive.
Definitely. Now, Escumber's background is a little different. He was born in Spain and studied mathematics.
At the University of Murcia.
That's right. And he's been a professor there since 1999.
But he's done more than just teaching and research.
Yeah. He's also held administrative positions in education.
Like what?
Well, he was an assessor for the Regional Minister of Education and Culture in Spain.
So he's seen the world of education from different angles.
Exactly. And that's probably given him a unique perspective on the challenges facing educators.
Makes sense. So he's not just a software developer. He's an educator who understands the needs of teachers and students.
That's a good way to put it.
Yeah?
And like Christian, he's very active in professional organizations that promote the use of technology in science education.
Like which ones?
Well, he's the president of the Multimedia in Physics Teaching and Learning Group.
Okay.
And he's also president of the CoLOS Association.
So both of these guys are really dedicated to making science education better.
Yeah, they're both amazing.
It's inspiring to see people who are so passionate about what they do.
It is. And it's clear that their passion is making a difference.
Yeah, they're really pushing the boundaries of what's possible in physics education.
And hopefully they'll inspire others to do the same.
I think they will. So that's Wolfgang Christian and Francisco Escumber, two pioneers in the world of physics education.
And their work is having a real impact on how physics is taught around the world.
Yeah, it's an exciting time to be involved in this field.
It is.
Yeah.
And I can't wait to see what the future holds. They really seem to have a broad vision for this whole thing, you know?
Yeah, for sure. So we've talked about who these guys are and what they were trying to do, but what did the workshop actually look like? Like, what were the teachers doing day to day?
Well, it ran for 4 days, from November 25th to the 28th, 2014. And it was held at the Academy of Singapore Teachers. They had a pretty packed schedule.
Okay, so walk me through it. What happened on day one?
Day one was all about the basics, getting everyone comfortable with computational modeling and the easy JavaScript Simulations software.
EjsS.
Yep, EjsS. They started with the fundamentals, like how to represent physical systems in the software, how to define variables and relationships, how to build a basic simulation.
So it was like a crash course in simulation building.
Yeah, pretty much.
Yeah.
But they made it really accessible even for teachers who didn't have a lot of experience with programming.
I was going to ask about that. I mean, simulations sound kind of intimidating, like you need to know how to code and stuff.
You'd think so, right?
Yeah.
But that's where Christian and Escumber's experience as educators really came in handy. They designed the workshop to be easy to follow. They broke things down into small steps, gave tons of examples, and offered a lot of support. So even if you were a complete beginner, you can still succeed.
That's good. I mean, you don't want to scare people away on the first day.
Right, exactly.
Yeah.
And they didn't just focus on the technical stuff. They also talked about the teaching side of things. Like, how can you use simulations to help students learn? What kind of activities can you create? They really wanted teachers to think about how to integrate these tools into their classrooms.
That makes sense. It's not just about the technology itself. It's about how you use it.
Exactly.
Okay.
Okay, so that was day one. Now, day two got even more interesting.
Oh, yeah. Why is that?
Well, they brought in people from the Ministry of Education.
No way. Like high-level officials.
Yeah, people from the Curriculum Planning and Development Division. They wanted to talk about the bigger picture of education in Singapore.
So they were thinking beyond just physics.
Oh, yeah. They talked about blended learning, MOOCs, open educational resources, teacher learning communities, It was a really wide-ranging discussion.
Wow, so they were really trying to connect these open source tools to a larger vision for education.
They were. It was pretty impressive.
Yeah.
And it shows just how seriously they were taking this whole initiative. Yeah, for sure. Okay, so day 2 was all about the big picture. What about day 3? Did they get back to the nitty-gritty of simulation building?
They did. Day 3 was all about taking things to the next level. The teachers started working on more complex simulations, and they were encouraged to start thinking about specific learning challenges that they could address with these simulations.
So they were really starting to apply what they learned to their own classrooms.
Yeah, and they were given a lot of freedom to explore and experiment. They could work on their own, they could consult with Christian and Escumber, they could collaborate with each other.
That sounds like a good learning environment, not too rigid.
Yeah, it was. And it allowed the teachers to really take ownership of their learning.
Okay, so day 3 was all about exploration and experimentation. What about day 4? How did they wrap things up?
Day 4 was about sharing and reflecting. The teachers got to present their work to each other and get feedback.
Like a mini conference?
Exactly. And it was a chance for them to celebrate their accomplishments and to share what they learned with each other. It must have been pretty inspiring to see what everyone had created.
It was.
Yeah.
And it really reinforced that sense of community. Like they were all part of something bigger than themselves.
Yeah, that's powerful. So the workshop ended on a high note.
It did.
Yeah.
And to make it even more official, they had a public lecture at the National Institute of Education.
Wow, so they were really spreading the word.
They were. They wanted to share what they'd learned with a wider audience and to show the potential of open source education.
So it wasn't just about those 20 teachers, it was about starting a movement.
Exactly. And from what I can tell, it worked. In the weeks and months after the workshop, those teachers started creating and sharing their own simulations. And a whole community of educators emerged, all connected by this passion for using technology to improve physics education.
That's amazing. It's like that workshop planted a seed and it just kept growing.
It did. And it shows what's possible when you bring together talented people, give them the right tools, and create a supportive environment.
So inspiring. Okay, so we've talked a lot about EjsS, but I have to admit, I'm still a little fuzzy on what it actually is. Can you break it down for me?
Sure. So EjsS stands for Easy Java JavaScript Simulations. And it's basically a software program that lets you create interactive simulations. But don't worry, you don't need to be a coding expert to use it.
Oh, good, because that's not my strong suit.
It's designed to be user-friendly. It uses a graphical user interface, which means you can create simulations by dragging, dropping elements, setting parameters, and defining relationships between objects.
So it's more visual, less about typing in code.
Exactly. And there are tons of tutorials, examples, and a supportive online community to help you along the way.
So even if you get stuck, you've got people to turn to.
Yep. And another cool thing about EjsS is that it's integrated with the open source physics code library. So you have access to this huge collection of Java programs that model all sorts of physical phenomena.
Ah, so you don't have to start from scratch every time.
Right? You can use those pre-built components as a starting point and then adapt them to your needs. And because it's open source, you can even tweak the code if you want to.
That's awesome. So it's like having a giant toolbox of physics simulations at your fingertips.
Exactly. And the open source nature of it encourages collaboration. People are constantly sharing their creations and building on each other's work. It's a really cool community.
I love that. Okay, so EjsS is pretty amazing, but let's circle back to the guys who created it and who led this workshop, Wolfgang Christian and Francisco Escumbre. They're both fascinating figures. Can you tell me a little bit more about their backgrounds?
Sure. So Christian's story starts back in 1970 when he got his bachelor's degree in physics from North Carolina State University.
Okay.
He went on to get his PhD there too, focusing on physics research. So he had a strong foundation in the theoretical side of things.
Yeah, he's definitely got the brains.
Oh, yeah. But he didn't just stay in the lab. He started teaching at Davidson College in 1983 and quickly realized that he loved it.
And he had a knack for explaining complex concepts in a way that students could understand.
He did. And he was also one of the first people to see the potential of computers for teaching physics.
So he was kind of a visionary in that way.
He was. And he was really active in the physics education community. He was involved in professional organizations like the American Association of Physics Teachers. And he was always advocating for innovation in teaching.
And he's won some pretty prestigious awards too, right?
He has.
Yeah.
He won the Pegram Award for Excellence in the Teaching of Physics, and he's a fellow of the American Physical Society.
Wow, that's a big deal.
It is. Okay. Now, Escumber's background is a little bit different. He was born in Spain and studied mathematics at the University of Murcia.
Okay.
And he's been a professor there since 1999. But what's interesting is that he's also worked in educational administration.
Really? Like what kind of roles?
Well, he was an assessor for the regional minister of education and culture in Spain.
So he's seen the world of education from both sides, from the classroom and from the policy level.
Exactly. And that probably gives him a unique perspective on the challenges facing educators.
Yeah, for sure. So he's not just a tech guy, he's an educator who understands the system.
That's a good way to put it.
Yeah.
And like Christian, he's been very active in professional organizations that promote the use of technology in science education.
Like which ones?
Well, he's the president of the Multimedia in Physics Teaching and Learning Group, which is sponsored by the European Physical Society. And he's also president of the Colos Association, which is an international group focused on using computers in science education.
Man, these guys are busy, so they're both really committed to improving science education.
They are. And they're both incredibly talented and dedicated.
It's inspiring to see people who are so passionate about what they do.
It is.
Yeah.
It makes you realize that change is possible. If we can find ways to support and encourage innovative educators like Christian and Esquember, then we could really make a difference in how science is taught.
Yeah, I totally agree. Okay, so we've talked about a lot, but what really stands out to you as the most important thing we've learned?
That's a good question. I think for me, it's the power of open educational resources, like the open source physics project that Wolfgang Christian started.
Yeah.
It's really about making knowledge available to everyone.
Yeah, it's like breaking down those barriers and saying, hey, physics is for everyone, not just the elite.
Exactly. And this workshop in Singapore took that idea even further. They didn't just want teachers to use those resources, they wanted them to create their own and share them with the world.
So it's not just about consuming knowledge, it's about producing it too.
Right, and that could apply to any subject, not just physics. Imagine teachers in all fields having access to this huge library of open source materials and being able to contribute their own ideas.
That would be amazing. But are there any challenges in making that happen?
Well, one challenge is just getting the word out.
Yeah.
A lot of teachers might not even know about open educational resources.
So we need to raise awareness.
Yeah, definitely. And then there's the issue of support. Even if teachers know about these resources, they might not have the time or the training to use them effectively.
So it's not just about providing access, it's about providing support too.
Exactly. And that's where things like this workshop in Singapore come in. They provide a model for professional development that goes beyond just the technical stuff. They create a community where teachers can learn from each other and support each other.
That's so important. It's like building a network of innovators.
Yeah, and that network needs to extend beyond just the school level. Policymakers and educational leaders need to be involved too. They need to provide funding, create incentives, and make sure schools have the infrastructure to support these new approaches to teaching.
So it's a system-wide change.
It is. We need to move away from this idea of education as just passively absorbing information and towards a more active and engaging approach.
Where students are creating and collaborating and problem solving.
Exactly. And technology can play a big role in that shift. But we need to be thoughtful about how we use it. It's a tool. And like any tool, it can be used for good or for bad.
Right. We need to make sure it's serving the needs of students and teachers, not the other way around.
And we need to be mindful of equity. We don't want to create a situation where some students have access to these amazing resources while others are left behind.
So it's not just about access, it's about equitable access.
Exactly. It's a complex issue. But I think this workshop in Singapore shows us what's possible when we bring together talented educators, cutting-edge technology, and a commitment to equity and innovation.
It's a really inspiring story. It gives me hope for the future of education.
Me too. It shows that change is possible. And it reminds us that we all have a role to play in shaping that change.
So what can our listeners do to get involved?
Well, they can start by learning more about open educational resources and the tools that are available. There are tons of great websites and organizations out there. They can also talk to their kids' teachers and school administrators about incorporating these resources into the curriculum.
And they can support organizations that are working to promote innovation in education.
Exactly. Every little bit helps.
Well, this has been a fascinating deep dive. It's really made me think about the future of education in a new way.
Me too. It's been a pleasure talking with you about this.
Likewise. So to our listeners out there, keep exploring, keep learning, and keep pushing for change in education.
And remember, the future is what we make it.
Thanks for joining us on this deep dive.
It was my pleasure.